Good morning. This is Constantine Romano, Solutions Architect with Step CG.
So today we're going to present benefits of Fabric and ongoing administration. And today will be Fabric fundamentals. So with that, just get started. Um, so here's the agenda for the next couple weeks. Today, of course, we're covering the Fabric fundamentals, and then on the 8th, we're covering Fabric and security, and then on the 15th, we're covering advanced concepts. So let's kind of set the stage here for what we're doing today. We kind of have to understand where we're coming from to get to where we need to get to. So you'll notice here we're looking at Jetson technology running on Flintstones networking. We're looking at today we have a lot of technology, smartphones, artificial intelligence is really starting to hit now. We have a bunch of IoT devices. We have sensors, beacons, laptops, iPads, you name it, etc. We have devices everywhere that need to connect everywhere. Uh, Extreme calls this the infinite enterprise, where we really need to be connected no matter where we are. So we need to be dynamic, we need to be mobile, we need to be real time. And the problem is that we have a network that's somewhat outdated. To these legacy networks, we have data protocols, protocol on top of protocol. We have um, the architecture that really built for static environments that weren't really created to be dynamic, 0-day changes scenarios. So today we're going to kind of go over how that's really changing. And go ahead, Constantine, why don't you present this slide here?
Yeah, hey, thanks a lot, Jim. So we want to start kind of by reviewing briefly the technologies that got us here, right? Where have we been coming over the past 30 plus years of networking, right? So we're looking at the introduction of spanning tree protocol. It says here 1992, but it actually goes back a little bit further than that. OSPF a little bit later on, BGP, certainly multicast. I know a lot of you are running multicast in your environments as well, right? Shortest path bridging kind of takes the functionality of all these technologies and puts it together. Okay, so that is a key thing that we want to point out is that shortest path bridging is not a proprietary technology. It is a ratified standard by both the IEEE and the IETF. So you can see that you've got the RFCs and the 802.1q standards listed there. Traditionally comes out of the provider space, but with Extreme, now that's being brought into the enterprise space as well.
Yes, so just to add on to that, Constantine. So once again, we have these two major protocols. We have IEEE and IETF, the governing bodies of the internet. So everything is every protocol that's known to mankind today on the internet is developed by either one of or ratified by either one of those two governing bodies. You'll notice that that shortest path bridging is actually ratified by both. Typically, both of these bodies only really agree on a couple of things. IP is one of them, and shortest path bridging is the other one. So what exactly is Fabric?
Hey, thanks, Jim. So yeah, like we said, it's based on enhanced shortest path bridging, and they're the standards that apply. Some key points that we want to talk about. And I really don't want to, I don't want to read a slide to you guys, right? But there are some key things. One control plane for all the network services, and what that means is that your control plane and your data plane are getting separated, right? You're not running control and data on the same plane. Services are only going to be configured at the Fabric edge. So if you need to extend services through your network, and we're going to see how that's going to work a little bit later, but you provision them at each end, and the shortest path bridging network will create those connections on an automated basis, meaning that you don't have to touch multiple devices in your network to create those end-to-end connections, right? So the fewer devices you touch, And I think any of us that have been doing this for a while, I know that I certainly fall in this category. The fewer devices you touch, the less likely you are to break something, right? And we could all, I think, all tell war stories about that, right? The fabric infrastructure, as we kind of touched on this a moment ago, it's self-forming, self-provisioning, highly scalable. It does enable multi-tenancy for those that need it, and or easy network segmentation. And want to point out, from a multicast standpoint, it's a lot easier to set up than the traditional PIM DVMRP type multicast management protocols. Jim, you want to add anything to that?
Yeah, I mean, this slide here once again kind of goes over the protocols. Number one there with the two main governing bodies. That's kind of key to remember. One control plane, data plane, and the control plane are totally separate with short path bridging, and we'll go into more detail as we get into the slides here. But all services are only ever configured at the fabric edge is one of the keys here, and with Extreme NAC we can also actually make all these different services much easier to, and kind of like a zero touch scenario. So let's move on.
Yeah. Very good.
All right, so let's kind of go over some of the basics here. So you'll notice, somewhat of a corporate network here, enterprise network. Once again, there's those two protocols that are ratified by IEEE and IETF. 802.1AQ is IEEE, and RFC 6329 is along with 802.1H there are the protocols here that are ratified. So kind of up top there, you're kind of seeing a Fabric Connect network. You have your core, you have your campus, you have your down the bottom right there, you have your data centers 1 and 2, and kind of today's is kind of how things are connected in our enterprise network. We have everything connected, and so Fabric Connects kind of makes connects all these different devices, all these different parts of our network. You'll notice that there's a bunch of connections there that are triangles and whatnot. So with short path bridging, we kind of say create your triangles as much as you can, because as Constantine mentioned, there is no spanning tree in this network. Everything is created by is controlled by the protocol itself. So it's a loop-free topology. So we say create your triangles which is redundancy. The other part of Fabric or short path bridging is Fabric Attach. You'll notice here at the bottom left-hand side you have your IDFs, your closets, and we connect them using Fabric Attach. So a little bit of different protocol, but it's same technology, so that everything can be connected at the edges, as we mentioned in the last slide as well. So provision at the edges. When you do that, you get away from the fat finger scenarios in the core. And then last but not least is that Fabric Extend. We have our network that is extended across the carrier network. And with Fabric Extend, we can actually make that network, no matter where it is, whether it's down the street, around the world, we can make it look like it's in the same building, same enterprise. Nothing changes. Our services get extended across there, just like they're in the same building. So, Constantine, anything to add on that slide there?
Yeah, I do actually. Thanks, Jim. So a couple of, one major point I want to make. So Fabric Extend technology allows you to, as Jim mentioned, go across a carrier network and extend the fabric through that. So what that means, for example, in an educational environment, a lot of times you might be using a particular carrier, say AT&T, Windstream, whatever, to provide the wide area connectivity between your different schools. And we can use Fabric Extend through that carrier's network to invisibly tie everything together, right? Rather than having to have it a routed network or something like that, they can still be part of the fabric, and we have done that at several districts in Kentucky as well as other places. So the point is that we have the capability to extend the fabric without relying on a particular underlying infrastructure to do so. And
Yeah,
I
great
think
point there.
that's it for me.
Yeah, great point. So let's kind of get to a little deeper in that thought process there. So you'll notice here we have a physical, we have a logical connection there. So the physical layer is ISIS. It's a protocol that's been around for late 80s, but it wasn't really used a whole lot. But so in short path bridging, we use that as the control plane. And the cool thing about short path bridging is that control plane and that data plane never coincide with each other. The data plane is just a service that rides across it. The switches involved in that control plane, they don't care what the service is. All they do is they transport that. Now, if it's a local service, obviously they're going to hand it off to whatever needs to be handed off to. But that control plane and that data plane are totally separate. So there is no flooding, learning. It's a loop-free topology, as I mentioned earlier. And the cool thing is that traffic always, always, always takes the shortest path from source to destination. On the data plane side, it's basically an Ethernet switch path. Kind of vision it as one big switch, if you would, where you have slot 1 through slot 10, for example, and just the data goes from slot to slot, switch to switch, port to port, etc. The SPB is that next generation VLAN. Inside of that, we kind of get rid of the VLAN, if you would. We give it what we call an ISID, an inter-service identifier. We still use the VLANs at the edges, but they really only become edge significant. When we give that ISID, that's what gets transported across the network and gets goes edge to edge, etc. So because of that, we kind of get rid of the scaling limitations. We all know that with VLANs, we have 4,096. When we use ISIDs, we now have the ability to do 16 million ISIDs, which really equates to 16 million VLANs. We also get rid of the MAC explosion scenario that we're all used to. So, today, our competitors sell larger switches with more memory because they have to worry about every MAC address. With short path bridging, the MAC is only significant at the edges because we encapsulate that MAC. Thus, the SPB MAC, M for the MAC and MAC encapsulation. So we encapsulate that MAC address at the edges, and then it gets sent across with the services to wherever it's going to and gets de-encapsulated on the far end. So no tunneling here. Everything is, once again, that control plane and that data plane are separate. And we have a couple of different ways to virtualize technology. We have what we call a layer 2 virtual service network, which is really nothing more than a VLAN that we typically today would actually tag across our whole network. We also have what we call IP shortcuts, which is really a routing, what OSPF would be to us. And then we also do what we can do, we call a layer 3 virtual service network, which if you're using VRFs and things like that, that's the technology we're talking about that. We won't go deep in that technology today, but we will get it somewhat into the weeds with the first two I mentioned. Constantine, you have anything to add?
Yeah, no, I think you made the points really well, Jim, that we're keeping things independent, the logical from the physical, and virtualizing. One thing that you touched on about switches not having to maintain MAC address tables for the entire network is a key thing, because it allows us to do more with more lightweight hardware. So yeah, let's go ahead and move on.
Okay, so you'll notice on the left-hand side here we have we're showing Fabric Connect short path bridging. So Ethernet at the layer there, and then we have ISIS as the control plane. Really, it comes down to everything is one protocol with short path bridging. It's one of the reasons why the governing bodies ratified it. It's really just one protocol with it encapsulates everything that we use today: routing, multicast, et cetera, et cetera. So it's faster to deploy, stability, troubleshooting is so much easier. If a switch dies, the recovery is so much faster, sub-second recovery. Where on the right-hand side, we have our typical protocols we've been using today, where we start with Ethernet, we add we add OSPF or some routing protocol. It doesn't have to be OSPF, but RIP, BGP, etc. And then we add some protocol independent multicast. We all know that's really not independent. It rides upon a routing protocol. And then we have um, our overlay networks like VXLAN, where it really has a control plane of LASP, and as well as the segmentation part of it, which is the trust security there. So they're really not separate. They're overlay on top of a network. So those control planes and data planes are not separate there. It's an overlay network running on top of IP. So if that underlying protocol dies, OSPF, for example, if it dies, everything comes down like a card, house of cards there. And to put to add on there, these protocols require a controller. So it's somewhat complex today. We got more complex rather than simpler. So on the left-hand side, we're simple. It's IP and Ethernet, one protocol, and then we add services on top of that control plane to get our data services.
So
anything to add?
Yeah, if you don't mind if I jump in here, Jim. So I think the key takeaway from this slide, if I may, is that when you're talking about fabric, you're talking about shortest path bridging. What you're talking about fundamentally is a rethinking of how networking is done, right? It's and we'll actually get into a little bit more detail on that concept on the next slide, but whereas on the right-hand side, you see a patchwork of protocols and services that were kind of added together to deliver, to try to deliver a sense of simplicity. They really don't, because a lot of these protocols, Lisp and TrustSec, for example, are not industry aligned. They're not industry standard, not necessarily ratified. Whereas with ISIS, the idea was to take a step back and say, wait a minute, do we really need to be throwing a bunch of different protocols that are kind of interrelated and talking to one another? And if one thing breaks, everything breaks. Or is it better to kind of start from the ground up and do a fully integrated fabric technology? And that's the simplicity and ease of management that fabric represents here. So.
And that's a great point. I love that point where, on the fabrics on the right hand side there, they're not ratified. Both the governing bodies, IEEE and IETF, looked at fabrics, and they ratified as short path bridging. The protocols, fabrics on the right hand side, have not been ratified, and they probably will never be ratified. So, some cool technology here today. So. As Yoda said, you must, unlearn you must, what learned you have. And really, the concept here is, we really need to unlearn what we've learned in the past. So as we go through this today, keep an open mind. Kind of what the point Yoda's getting to. This protocol is different than everything you've ever seen, unless you've already using it today, obviously. But if you haven't seen this protocol, keep an open mind, because it's totally different. Your routing that you use today, where you have to touch multiple switches, it's different here. So just keep an open mind as we go throughout the rest of this presentation today. So today's segment, common network segmentation, VLANs with ACLs, complex. Lack scale. We're using the global routing table to do everything. So if you add some rule, you may have to make sure that you worry about the rest of the rules that are there. Distributed firewalls, we put firewalls everywhere because we want to control that traffic. So the more firewalls you add, the higher that CapEx and OpEx become. And then you have additional protocols on the right hand side there, IP VPNs, PRF, MPLS, etc., which is that segmentation, routing table where we segmentate the router, and then we have those overlay tunnels, VXLAN, IPsec, GRE, etc. And we're going to show you a better way to do this today, how we can still get some of this technology, but there's a better way to do it using short path bridging. You don't need as many ACLs. You don't need the distributed firewalls, because the fabric is inherently secure. We segmentation as much as we want to. We call that hyper segmentation. So you can hyper segmentation every part of your network and not worrying about one part of your network bleeding over to another. if a hacker were to get into one segment, there's no way to jump from service to service, as you'll see in a little while here. Um, so inherently secure is the kind of the theme here is that no matter how you lay your network out, it's inherently secure. We've done multiple hackathons using the fabric. We've had MIT, we've had a group from Dubai who, Hacker World. We had the fabric in Sochi Olympics. 21 days there. It's kind of like having a Super Bowl 3 times a day for 21 days scenario. So in the middle of the hacker world there, we had 0 hacks. We hyper segmented everything there, and once again 0 hacks, and that's been proven over and over again. Even with the hackathons, MIT was not able to hack it. All the different hackathons, nobody's been able to hack this yet. So once again, inherently secure, and that's kind of the key here.
Yeah, and Jim, I'm glad you mentioned the Olympics, because if you guys are watching the Sochi Olympics, every bit of video and audio that you saw went through a fabric network.
Exactly. Yep.
That was set up by a small number of engineers. I think it was like 5 or 6 people. 5 or 6 people set it up in a couple of days.
Yeah, exactly. And we've done interop and things like that. We have multiple stories like that. Be glad to share them with you. But typically, when our competitors go in, they send a troop in. We to set up the Sochi Olympics. We had 4 guys that showed up about a week or 2 before, laid everything in. The part of the issue that we had with the Sochi Olympics was the power grid when we first got there was not what it needed to be. So every day they would drop out during the day. So we had to make sure we backed everything up, things like that. So a lot of issues there during that setup time. But once again, 3 to 4 guys could set this whole network up. This was multi-site, so spread around the region there, all fabric nodes, etc. So once again, very secure. So moving on here. So the status quo here on the left-hand side, you'll notice a typical network here, multiple switches here getting routed. It's a hop by hop provision. So if I want to add a VLAN, say for example on the bottom, I need to make sure that it goes in the network goes in the route table. I may or may not need to configure the rest of the routers, but it will be picked up on all the router tables there. In today's status quo network, moves, add changes require typically a core reconfiguration, vulnerable to the human error, the fat finger, etc. Services are typically in this status quo network today are typically coupled to the physical topology. So we got to worry about where the switches are, what the path is going through is, things like that. Whereas on the right-hand side with Extreme Fabric Connect, we provision at the edges only, and that's kind of the key here. We provision only. If I can only provision at the edge, right? The only thing I can actually affect if I make a fat fingering issue is that one edge port where I'm configuring it. It will not affect anything else in the network. So I want to worry about bringing a switch down. I want to worry about spanning tree, causing a loop, and bringing the network down, et cetera, stuff that we're used to today. I don't have to worry about that because I'm configuring one port at the edge and I configure it somewhere at the far edge, and my service that gets transported no matter how many switches in the middle. I'm not showing you any switches in here in the middle, but no matter how many switches in the middle, it gets transported across them. So kind of view it as an airport, for example. If I want to go from Philadelphia to Los Angeles, would I want to travel to every airport between here and there? Would become rather than a 5-hour trip, become like a 3-day trip, where typically your airplanes today, they take off in one airport and land at my destination. Hopefully, I get that 0 stop flight path. But in that scenario where it's 0 stops, I leave Philadelphia, I land in LA, and I'm happy. I don't need to see every airport between here and there. And this is fabric as essential airport where. At Essence, where we don't need to go through every switch. Every switch can see the packets, but they're not a part of the service. They just pass it on. And so we don't have to worry about those move out changes as we have today because we're only affecting that edge port. So we can do 0-day changes. And we've had customers in hospitals and manufacturing plants, casinos, et cetera, et cetera. The list goes on and on. But we've had those customers that have made those changes in the middle of the day, and once again, it affects nothing. So we can get that service faster to deployment. We don't have to wait for that 30-day window, or that or get those add moves and changes approved by a governing body because we're only affecting ports at the very edges. So that bottom point there, services are abstracted from the topology. The topology independent is the key there. Constantine, anything to add?
Yeah, no, I mean, I think this slide does a fantastic job of kind of summarizing some of the benefits and what what the administrator's view is, right? Where you're provisioning on the edges and the network builds the links, advertises the connections and creates them automatically rather than having to touch multiple intermediate devices. So that's a key feature, and kind of like it's a saying in our industry, right? That there are two kinds of network engineers. Those are broken a network and those are going to. So
very true.
Yeah. So why don't we go ahead and go on to the next slide real quick? Okay. So this is the idea that Jim was talking about, right? Stealth networking. You have a path into the network, and it's a point A to point B, and you do not have doors that you can hack into on the left and right. So it's inherently more secure. And if we can move on, please. Same general idea, right? So same concept, different view, where your guests they get in, they go through the fabric, they go to the firewall, and they're out to the internet. They do not have access into anything, and they cannot touch anything in between because everything's invisible to them.
Yes. So to just add on to that,
Yeah.
So we're showing a guest network here, going from end to end. So hacker gets in there involved. They don't see anything, any of our financials or intellectual property, et cetera. And as we mentioned, we can hyper segment. So that doesn't have to be a guest network there. That could actually be the financials network or the intellectual property or the HR or you name the part of your organization. That tunnel, that hallway that can see nothing can be any one of those services, right? We can hyper segment those services to keep them separate so that they don't see those doorways on the right hand side. So no matter who it is, whether it's our HR or accounting department, those doors aren't seen by any of those other departments. So once again, inherently secure because that you cannot reach inside of, you can't go from a zone to a zone. So each one of these intellectual property, financials, HR, et cetera, they're a zone. We create those zones and they stay separate throughout the network, unless we allow them, through some other way like a firewall, et cetera. They're not going to get from zone to zone. So once again, inherently secure.
Yeah, and thanks for pointing that out because you're right. This slide does kind of, by using guest network as an example, it does kind of imply, that, but yeah, it covers all the services end to end. Right?
Yeah, it's not only guest networks, it's everything. Yes, yeah.
Right. Thank you. So here we're looking at again, it's going to be a comparison chart of the traditional. The way it was, traditionally done versus the way that we can do it with Fabric, right? So with that hypersegmentation, you really are limited to the degree that you can segment your services, right? There's a lot of complexity involved in implementing that kind of security, having to use access control lists, which are very cumbersome. And of course, if you have access control lists, you have to make sure that you have them on every device. And if you make one mistake, well, then now you've got a security hole potentially, right? If we look at the diagram on the right with hypersegmentation, because of the fact that it's all automated, you don't have to worry about, making a mistake. And we talked about potentially making a mistake earlier and bringing down the network, but you could also potentially make a mistake and allow a security hole where you didn't intend to, right? But with Fabric hypersegmentation, we don't have to worry about that, right? Because it is automated and edge provisioned. So one thing that's pointed out here, and I want to stress, is VLANs were not built for security, right? They were built for broadcast management. And a lot of times we see, in the past at least, we've seen VLANs kind of being used as a network segmentation method to provide security, but that's not really what they're good at. And the reason they're not good at it is because it's not difficult for a hacker to cross VLAN boundaries, right? We think it is, but it's actually not difficult to cross those boundaries. However, you can't do that with a fabric network. And the reason you can't do it with a fabric network is because the VLAN that you see at the edge doesn't mean anything to the fabric. So a hacker could potentially, quote unquote, hack a VLAN, but it won't matter because the fabric is going to say, I don't know what that is, and I'm going to ignore it, right? So Jim, anything you want to add on this one?
Yeah, that's a great point. As I mentioned earlier, we use ISIDs, that inter-service identifier, rather than the VLAN identifier. So the VLAN is only as significant. So the edge ports there, once it gets to the part of the fabric, it becomes an ISID, which gets transported across the network and then gets stripped off the other sides. And then as we go into the next couple of slides, you'll see how that's totally different from everything you do today. So each one of these, on the right-hand side, we see they're all zones. They're all secure zones because, as Constantine mentioned, you can't jump from zone to zone. They're inherently secure just based upon that alone. So no ACLs, as Constantine already mentioned. So no matter what we're doing, if we set up our network right, that segmentation becomes hyper, and it becomes somewhat effortlessly for our users to get the things because they don't really care where they get to. They just want to make sure everything works. But in the background, their network is very secure, and they may not realize that part of it. But that's the part that's as network individuals, we don't have to worry about those hackers getting from zone to zone because once again, it's inherently secure.
Awesome, thank you.
So a couple theories here, fabric theories. Some of this already mentioned there. Based upon established service paths, so once we set up those core switches using ISAS as the control plane, those switches all automatically know where everything is, and then they figure out where the service paths are as we overload those service paths on the data part of the network. So they've become established service paths. So although every switch may know about them, they don't need to be a part of the service paths. They just can become transports. And so that physical topology doesn't really matter there. Everything becomes a logical service point. So I mentioned earlier at layer 2's service points, we mentioned L3 IP routing, whether it be IPv4 or IPv6. The fabric can take care of that. We can local segment L3 IPVPNs, VRFs, if you would, both at a IPv4 and IPv6. So every protocol that you can do today, we can do it much easier with the fabric. Is kind of the point of this slide here. We embed the information inside of a fabric forward table, and we strip off the MAC address, we add it back on the far end, things like that. So the legacy protocols, they get replaced, no longer needed. No reason to use OSPF. RIP, not sure why you still be using that if you are, but sometimes it gets embedded there. We need to stick with it, but we don't need to use PIM because multicast is inherently part of the protocol. No BGP, no MPLS, no EIGRP, etc. There's no other protocols needed in the fabric because everything is built into one single protocol that take care of all these things that we've had to deal with in our legacy networks for years and years and years, back to the 90s, for example. some of them have been doing it that long. Some of you people are probably younger, but so you haven't had to deal with a lot of these protocols. But the point here is that we don't need them because everything's built into one protocol, short path bridging, which at the end of the day, it makes everything easier for us to deploy. It's an intelligent network and simple to deploy, and our job becomes much easier because of that. Constantine, anything to add?
I really, well, I really don't, but I do want to mention, there's so we see here the mention of BGP and MPLS and so on. So BGP, of course, Border Gateway Protocol, is the routing protocol used on the internet. So the switches, the fabric doesn't require it, but the switches can speak it, right? So if you're on, if you do have a switch that acts as your gateway into the internet, for example, and needs to run BGP, that capability exists, but we don't require it, right? So, but we can run fabric over a lot of these. So if you're dealing with a legacy network of some kind that requires OSPF, that requires MPLS, for example, right? As we talked about Fabric Extend earlier, we can run Fabric over those to still make those service connections seamlessly through the fabric, even riding on top of legacy non-fabric networks. Right? So, but that's really all I think to add on that.
Yeah, I was going to say that's a great point. That's that part of the Fabric Extend I mentioned earlier: Fabric Connect, Fabric Attach, and Fabric Extend. That's that Fabric Extend scenario where we can actually ride the protocol across those. We can also redistribute those inside the fabric as we need to. So if we have a legacy network, OSPF network, for example, I can actually redistribute that inside the fabric, so that route table will become one route table. So there's really nothing we can't do inside the fabric today, no matter what the protocols are at the edges. We can handle those protocols and add them into the fabric or run across them either way, so, as Constantine mentioned. So getting down the weeds here, Constantine, why don't you jump and take this slide?
Absolutely, happy to do so, Jim. So so how does Fabric Connect work? And we're gonna talk about some of the underlying technologies here. I'm gonna say I both love and hate slides like this because they've got a lot of information to them, but then it's I don't want to be reading it to you, right? So, but I do want to highlight some of the key points. SPBM, again, we said earlier that it's a ratified standard, right? So it rides on top of IEEE 802.1 AH MAC encapsulation, and we're going to see. I think we've got a subsequent slide that shows that. But that's the underlying technology that we're using for full network virtualization. Right, so you've got the MAC address of the switch and the MAC address of the end device, and that's how the traffic is transported through the network. The ISIS control plane, there is a single instance of a link state routing protocol. So if you're familiar with OSPF, for example, that is a link state protocol where all the devices on the network, all the nodes rather, maintain information about the link states of other nodes, right? And ISIS works in a similar way. It'll maintain a link state database that shows all the nodes on the network, how it gets to them, what the shortest path is to get to them. Right? The Ethernet data forwarding plane, it's kept simple. It's extremely capable. Like we said, it's fully topology independent, and the point that's being made about layer 2 forwarding for all layer 2 and layer 3 traffic, that's kind of going back to the concept of the services are integrated, right? So whether you're talking about just layer 2, extending layer 2 services through a network, if you're talking about advertising IP routes to the network, this functionality is all built into ISIS and doesn't require additional add-on pieces or additional protocols thrown on top. Spanning tree, yeah, so there's no spanning tree inside the fabric. The fabric manages the paths itself, and that kind of goes back to the link state concept we talked about a little bit ago. Now, you'll see in implementations and actual production implementations we use spanning tree at the edge, right? It's still very, very functional to prevent loops within a particular edge switch or edge stack, but that's where it ends. It does not, spanning tree doesn't propagate throughout the network. And if you've ever been part of a spanning tree reconvergence process that can take a network down for an extended period of time, that you see the automatic advantage of that. But the key thing is we're not flooding flooding MAC addresses in the fabric there. OAM, we're going to talk a little bit about configuration fault management, CFM, a little bit later. So, Jim, I don't know if you want to add anything on this.
No, I think you did a great job. And I think the only thing I would add would be, once again, I think that the third bullet there, with every protocol that we've used today is actually built into that one single protocol called, certified bridging. So no matter what it is, it's there ready for us to use, which is the reason why the governing bodies ratified this. So let's get into some terminology, because we use a ton of this in the industry. Every time we turn around, a acronym is being reused again. But I think some of these acronyms are somewhat needed to be known as we go further in this session today, as well as the upcoming session. So backbone edge bridge, backbone core bridge, you'll notice there in the middle there, we have a BCB, backbone core bridge. And really that's a bridge that kind of acts as a transport, if you would. So services are not on that bridge. So, and what I mean by services, there's ISIDs or VLANs that we mentioned earlier, that layer 2, layer 3, et cetera. The services that aren't there, he really just becomes like a traffic cop and moves traffic around. He can become a BEB, a backbone edge bridge, by adding a service to him. But typically we have these core routers today that kind of really do nothing but, they route everything in the middle. And with SBB, they basically become transports. They don't need to know about those route tables, etc. We kind of rename the VLANs to CVLANs, because those VLANs become only locally significant. So once again, those VLANs are created at the edge, and then when they get transported across the network using ISIDs. Backbone VLANs are the VLANs that we create, 2 VLANs to create that ISIS infrastructure out of the gate there, and they use those 2 VLANs to transport the data plane across them. So once we create them, no additional configurations are required on those bridges. Backbone MAC address is kind of the addresses that the BEBs, BCBs learn. And typically, once again, we mentioned earlier that those MAC addresses are kept locally at the edge there, at the uni ports. So that CMAC is that customer MAC learned at the very edges. And then when it gets to that next switch, the only thing those other switches need to know is the backbone MAC addresses. ISIDs, we mentioned that earlier, really just the service instance identifier. SPB, we've been talking about that. Hopefully you've heard us say that a couple of times today. CFM, that connectivity fault management, we'll go deeper in that in a couple of sessions here in the future. And then ISIS is that intermediate system, which is that control plane that transports the services across the fabric there. And then link state database, ISIS is a link state database protocol. So if a switch dies, there's that sub-second failover for the rest of the core switches there, and the shortest path will still be taken. And in that scenario, when a switch dies, the next shortest path will be taken. So faster recovery than we're used to today. And then type length values, we won't go into that too deep, but every service has a type length value that is added, and so you can actually look them at tables on all the switches. So if you want to know what's going on every switch, you can actually look at those tables and see what's going on in each one of those tables. So this is kind of one of the slides, and you can just take a screenshot of it, just to kind of keep as a handy note, if you would. So if we start talking about these acronyms, you'll know what they are and going forward. Okay, so let's get here. Let's go forward. All right, so let's jump into our first service. which is layer 2 service, and we call this a L2 VSN, layer 2 virtual service network. Today we call them basically a tag network. So I'm showing 3 switches here up top there in blue. If I want to create VLAN 10, I create the VLAN on the switch on the left-hand side. I create the same VLAN in the middle, and I do the same thing on the far right-hand side. I create the VLANs, and then I tag those interfaces that go from switch to switch to switch. If I go, if I add more switches, further in the network, I need to do this over and over again. If we look down the bottom, we do that edge configuration that we mentioned earlier. We create the VLAN on the left-hand side. We don't need to tag it. We just create it. It becomes a customer VLAN, as we mentioned in the last Eckerman slide there. We create the VLAN on the far right-hand side. Once again, edge provisioned. And then we give it an ISID. We're showing 20,010 here. It could be 10 if you want it to be. It could be anywhere between 1 and 16 million, because we have 16 million ISIDs we can create. We kind of use numbers here to kind of segment things so we know what they are. So for example, maybe 20,000 is our VLANs, and maybe our 30,000 whatever, or layer 3 virtual service network later on. We'll get into that. But the point here is that we can, those VLANs become only local significant at those edge ports. And then you'll notice a bunch of switches in the middle. It doesn't matter if it's 3, 5, 1,000 switches in the middle. They don't need to know where that VLAN is. They transport across using an ISID, and anybody with that ISID gets that VLAN at the edge ports there. So very simple to deploy. No switches in the middle to worry about. No fat finger, because if I fat finger, only these edge ports are affected. Whereas up top, if I fat finger something in the middle, I can bring my whole network down. And we have to, and up there we have to worry about spanning trees, so we can loop it real easy, things like that. So that bottom one there, no VLAN configuration across the network, edge only is the key there. Can I see anything to add there?
Yeah, no, Jim, I think you covered this really, really well, and this slide does a great job of demonstrating the the edge-only provisioning model that shortest path bridging is built upon. So, thank you for that, and we can move on.
All right, and then what about conventional fabric versus Fabric Connect? So. Typically, our competitors today will use that VXLAN overlay here. So we're GRE tunnel. Once again, in this scenario, we have a route table involved, where each one of those routers and switches have to have a route table now, so they can talk to each other. So once again, you have to configure every switch to do this this overlay, if you would, that VXLAN overlay, which is kind of like layer 2 virtual service network to us, but once again, there's an IP underlay there that has to be configured to have that VXLAN overlay. So VLAN 10 can talk to VLAN 10. There's a bunch of configuration there, and it goes on and on and on. Whereas down the bottom there, once again, it's that, as we mentioned in the last slide, exactly the same thing. I configure on the left, I configure on the right, give it an ISID, done. It can't be more simple than that. Why have the complexity up top when I can make everything simple down the bottom? So, Constantine, why don't you jump in and take care of this slide here? I don't know. Let me know.
I'm so happy to do that. Yep, absolutely. So yeah, let's go ahead and step through it. We talk about ease of configuration. So what this slide's going to do is actually going to show you what that means, right? On the left-hand side, we're looking at, doing some standard configuration commands on a legacy non-fabric network, right? So you're running a layer 2 virtual private network over MPLS, and boy howdy, I wish we could kind of skip through to the end of there we go. All right, so you see all that series of commands. I think about 12 or so commands there, and you'd have to do that basically on every switch, every intermediate device across the network that has to pass this virtual private network. On the other side, on the right-hand side, you see the comparatively comparing to what you do on a fabric network, and you run that simple command. You map the edge VLAN to the ISID, which is set as the fabric construct. You do that on whatever edge device you want to participate in that service, and that's all you have to do. One command at the edge exclusively. So, done.
That's
Right.
pretty cool technology there. Yep. It's slick.
Yep. Absolutely. So yeah.
Where on the left-hand side, you're doing that, as you mentioned, every switch, which can be very tedious. Fat fingering scenario jumps in as well. Whereas we configure VLAN 7 here with ISID 700 and done.
Yep. Cool. Can we go to the next slide, please?
Okay, so let's jump into how we route. So obviously SPP can use the routing protocol as well. So up top there, we're showing a typical unicast routing table where we configure subnet on the left-hand side, but we needed to talk to a subnet on the right-hand side, and we typically know today that if this is an error, if these are could be two host subnet scenario where every router needs to be configured with some type of routing protocol in it, so that we can go a hop by hop routing. So with a route tables involved in every one of these switches, they know. Every one of these switches know about VLAN 11 or VLAN 12 because they have to transport it across the route. And there's that RIP again. Hopefully we're not using that. But the key there is that there's a routing protocol in every one of those 5 switches. And every one of the 5 switches need to know about those VLANs, VLANs 10.1.2 and 10.2.1. They need to know about that to transport it across. If we move down the bottom there, we have VLAN 11 on the left-hand side, VLAN 12 as we do up top there. But the main difference is that those switches in the router, doesn't matter if it's 1 or 1,000 switches in the middle there in the fabric, they do not learn about the route tables. He said again, they do not learn about the route tables of those edge BEBs there. Only the BEBs that are involved in that service or that route table need to learn about it. So once again, no fat finger in the middle to worry about. There's no route tables that have to worry about getting over big and things like that. So there is no OSPF in the scores I mentioned earlier. Those switches in the middle are just transports, and that IP reachability gives each one of those switches the ability to transport those routes across the network without learning them. So no VSNs required here. It's anybody that has that the IP shortcuts provisioned on it will learn the route and put it in their own local route table. Constantine, anything to add?
Only that one of the things that doesn't get brought up is that a lot of the routing protocols mentioned at the top of the slide have hop limitations, right? Like with RIP, you can only have up to 16 hops across the network, which sounds like a lot, but it really isn't. But with IP shortcut, because of the fact that we only care about the source and destination, and we don't care about everything in between, because everything in between just builds the connection through the link state the link state database. You don't have to worry about that. Everything is basically a single hop away. So.
Yeah, learn that the IP reachability at the switch level, but once again, not the route tables isn't learned there. We'll go over this both the layer 2, the slide before this, as well as this one in the future sessions next week as well. We'll get probably a little deeper in the weeds there. I think we're at the end of our time slot today. So Michelle, I don't know if we have time for questions and answers, but if not, we can take them and answer them as they come in email follow up.
We can take some questions as long as we are finished with the presentation. We do have a question from John. It says, will we see the preview of the Fabric GUI or whatever new tools exist in one of these training sessions?
I'm not sure if we'll cover them in either one of these sessions. We'll probably do a follow up on that. One of the things that StepCG is really good at is we have some management tools, and typically we really don't need them, but we have what we call a zero-touch fabric, where really you just plug switches in, it kind of creates the fabric by itself, and then you can use your or what we call our XIQ site engine, which is the old XMC product that we kind of just renamed and cloudified. We use that to provision services inside the network. So the zero-touch fabric and zero-touch provisioning become a reality using that product. We'll probably go over that in some maybe future session, but in reality, just so you know that we do have the tools to make things simpler. But as I mentioned, you plug a switch into another switch and they automatically figure out what's going on at the port level. So they create the fabric, or they add, a DCP, a camera, whatever. Everything becomes somewhat automated. But great question, and maybe something to think about as we go forward. But maybe we can do a demo at the end of the third session on how everything kind of connects together. Probably a great point there, but thank you. Any additional questions, Michelle?
That's the only one that we had right now.
Right,
And if anybody has any other questions, you can feel free to email me at mcrowley@stepcg.com, and I can get answers for you and send them to you. I did post in the chat that at the end of the 3 webinars, we will send out a copy of the presentation. I know that's always a question that we get at the end. We will definitely give everybody a copy of this that has registered for the webinar series. We apologize for the technical difficulties at the beginning of the webinar that we got started a little bit late. So hopefully we'll see you next week and the following week in the webinar series. Other than that, I believe that is a wrap for us today. Hope everybody has a great day today. Thank you very much.
Thank you, guys.
Thanks, everybody.